Hello guys. The last time we did part 1 of this particular video in dealing with an derivation of equation in capacitors, and today we have a question that says 3 capacitors each of 100 nanofarad are charged to 500 volts and then connected in series. Determine A, the potential difference between the end plate, B, the charge on each capacitor, C, the energy stored in the system. But before we go ahead, let's explain what is happening here. It said 3 capacitors each of 100 nanofarad are charged to 500 volts. That is the first question. Then I said, then connected in series. Let's take the solution here, please. Data given. Data given. We have our capacitance, which is equals to 100 nanofarad. This 100 nanofarad is same as 100 multiplied by 10 raised to the minus 9 farad. And this particular capacitor is charged to a volt of 500 volts. So before connection to series, or the initial connection, or we can put it the same as before connecting to series, before connecting to series, our charge is equals to CV. Our charge is equals to CV. So we have our charge, which is equals to our capacitor is equals to, our capacitor is equals to 100 times 10 raised to the power of minus 9 farad. So multiply by 500 volts. So this we are going to get. Now with this, you can go ahead and multiply. 500 multiplied by 100 multiplied by 500 is still okay, which we can have it as 50,000, because 100 multiplied by 500, we got 50,000 multiplied by 10 raised to the power of minus 9. So at this point here, we can actually also get 5.0 times 10 raised to the power minus 9. We have this point 1, 2, 3, 4 minus 9 plus 4. So at this point, we're going to get 5.0 times 10 raised to the power minus 5 coulomb. Now let's calculate our first question. Potential difference between the end plate. But here they say that we know that our data, let's keep it our data. Our given data, and the one we actually find, we have our charge to be 5.0 times 10 raised to the power minus 5 coulomb. We have our capacitor 1, because they say 3 capacitor. Our capacitor 1 is 100 nanofarad times 10 raised to the power minus 9 farad. Our capacitor 2, we have 100 times 10 raised to the power minus 9 farad. And our also capacitor 3 is equals to 100 times 10 raised to the power minus 9 farad. We are to calculate in series what is the combination, what is the total capacitor in series. Now in series, when we are calculating in series, there are two calculations, whether maybe it might be connected in parallel or in series. In series, we have our calculation this way, that we want to calculate the combination of the 3 capacitors. We have it as Cn. That means the C number of the capacitor is equals to C over C1 plus 1 over C2 plus 1 over C3 if it is connected in series. But if it is connected in parallel, this is series, please, connection in series. But if it is connected in parallel, it means our Cn, the number of the capacitor, is equal to C1 plus C2 plus C3. This is if it is connected in parallel. And before we go on, we should understand something here. We should understand this statement that when a circuit with a capacitor is connected in parallel, the total charge that flow in the circuit is equal among all these capacitor, and the voltage is also equal. But in the case of a series, the total charge is equal. That means if you look at the question number 2, they say determine the charge on each capacitor. Determine the charge on each capacitor. So if we got this particular charge, like this particular charge we already got here, this is the total charge that flow in. Then we have even gotten this. So we are going to address this particular answer. So the total charge is. But in the case of the voltage is divided among all the 3 capacitors. This connecting in capacitor in series. So therefore we have 1 over Cn is equals to 1 over our C1, which is 100 times 10 raised to the power of minus 9. So plus 1 over 100 times 10 raised to the power of minus 9. So plus 1 over 100 times 10 raised to the power minus 9. So we have 1 over Cn is equals to 1 over, I'm going to take this as 1 times 10 raised to the power of minus 9 plus 2, because this was 100. So the 100, I take the double 0 and count it as 2 here. So we're going to have plus 1 over 1 times 10 raised to the power of minus 9 plus 2 plus 1 over 1 times 10 raised to the power of minus 9 plus 2. So at this point we have 1 over Cn, which is equals to 1 over 1 times 10 raised to the power of minus 7 plus 1 over times 10 raised to the power of minus 7 plus 1 over 1 times 10 raised to the power of minus 7. Now, at this point here now, we can actually say that this 10 raised to the minus 7, when it go to the numerator, it becomes positive. So we are going to have something like 1 over C, number of capacitor, is equals to 10 raised to the power of 7 over 1 plus 10 raised to the power of 7 over 1. So the minus is out, plus 10 raised to the power of 7 over 1. So at this point here now, we got something like 1 over Cn is equals to, so if you have this, this is like it's 10 million. So this will give us 10 million, which is 70, plus 10 million plus 10 million. So this is just easy. We don't want to take it into indices, so that we just go direct. So 10 million plus 10 million plus 10 million will give us 30 million over 1. So therefore, we have 1 over Cn is equals to 30 million over 1. So at this point here, we cross multiply. So when we cross multiply, we are going to get something like 30 million is equals to 30 million Cn is equals to 1. So divide both sides by 30 million over 30 million. So please don't mind the space. We have 30 million. So 1 divided by 30 million, our Cn to be 3.3 times 10 raised to the power of minus 8 farad. 3.3 times 10 raised to the power of minus 8 farad.